Bismillahirrahmanirrahim. Assalamu alaikum. We're doing chapter 4, factorization and expansion. We have factorized the expression by breaking the midterm. We have expanded the expression. We have applied distributive law. We have done expansion using special algebraic identities. So now let's do factorization using algebraic identities. And we know that we have three algebraic identities: a plus b whole square, a minus b whole square, and then a square minus b square. So we'll be applying these three algebraic identities and we'll factorize the given expression. So let's do that. So taken a few questions from the book. So the first one, x square plus 12x plus 36. Okay, we have this expression and we have factorized it by midterm breaking method. So today let's factorize this by applying algebraic identity. And since if we look at the expression, all the terms are positive. So what we are going to do, we are going to apply a plus b whole square, and it is equal to a square plus 2ab plus b square. Now if we look at this and this is almost the same. So it means that we can apply a plus b whole square. How we are going to apply? So this is a is representing x squared. So what are we going to do? A square. So it is already a squared plus and plus 36. It is square of 6. So 6 square. So we have now b square. Now what do we need? 2ab, right? 2 into a. So a is representing x into b. So for b we have here 6. So we have this expression now, right? So this expression can be reduced to this. So x plus 6 whole square. So we have the factors x plus 6. Okay, and we can check it by midterm breaking method also. So if we were using midterm breaking, so what we have done, plus 12x plus 36. So coefficient of x square is 1. This is 36. So 36. So we need two factors. If we multiply, we get 36, and if we add or subtract, we get 12x. So the factors of 36 are 6. 6 into 6 is 36, and 6 plus 6 is 12. So x squared plus 6x plus 6x plus 36. So x is common, x plus 6. 6 is common, x plus 6. So we have here x plus 6 into x plus 6, which is x plus 6 whole square. So it is same. So we can solve by using algebraic identity as well. So let's take one more example. (25) b square plus 5bc plus 1 over 4 c square. So again, all the terms are positive. So we can apply a plus b whole square. What are we going to do? So let's apply this first. First term has to be squared. So a square. So 5b whole square plus. Why I am doing this term and then this term? So that we can know what is a, what is b, and then we can apply easily 2ab. So this is 1 over 2c whole square. So now we have a square we have b square. What do we need? 2ab. So 2 into this 5b is equivalent to a, so 5b into b. So 1 over 2c. Okay, this 2 goes with 2, so we have here 5b square plus 5bc plus 1 over 2c whole square. So we have this form now. So this can be reduced to 5b plus 1 over 2c whole square. So we have factors. Okay. Now let's take examples of this. A minus b whole square is equal to a square minus 2ab plus b square. So what is the difference? We have negative sign between a and b, and which will give us minus 2ab. So this is the difference. So let's take a couple of examples to use second identity. (36m square minus 48mn plus 16n square. So we have this expression, and if we look at this expression, we have a negative sign over here. So we have negative sign over here. So it means that this is the indication that we can apply second identity. So 36 is a square of 36. So 6m whole square plus 16 is the square of 4n whole square. So we have a, we have b, minus, because this is minus, 2 into 6m into 4n. Okay, so it will give us 2 into 6 is 12, 48, right? So we have a minus 2ab plus b square, so it will give us 6m plus 4n, sorry, minus 4n whole square. So we have our factors. So let's take one more example. One over 4 g square minus 1 over 4 gh plus 1 over 16 h square. So it looks, whenever we have fractions, it looks difficult, but it is not. If we see all the denominators are square of some number, so it's pretty easy. So what are we going to do? Since we have negative sign here, so we are going to apply identity number 2. So 1 over 2 g. So 4 is square of 2, so 1 over 2g whole square plus 16 is square of 4 h, so minus. What are we going to do? 2 into a, which is 1 over 2 g, then into b, 1 over 4 h. This goes with this, and we have 1 over 2 g whole square minus 1 over 4 gh plus 1 over 4 h square, so which is equivalent to 1 over 2g minus 1 over 4h whole square. So done, pretty easy, right? So now let's take third identity, which is equivalent to a plus b into a minus b. So now let's do that. Four c cube minus 49c. Okay, if we look at this expression, the first thing is we have a cube over here, right? so we cannot apply a square. So before we go for any identity, let's have some square variables. So what are we going to do? We have a cube here and a c here. So we can see that the c is common in both the terms. So what are we going to do? C is taken as common. So we have here 4c square minus 49. Now if we look at this expression and we come here, what it says, a square minus b square. So let's make it in the form of a square minus b square. So c, 4 is a square of 2, 2c whole square minus, this is square of 7, 7 square. Now if we look at this is a square minus b square, a square minus b square. So we can easily say that c into 2c plus 7 into 2c minus 7. So we have our factors by applying identity number 3. One more example. T square minus 1 whole square minus 9. Okay, this is already squared, so we have a square minus 9. So obviously 9 is the square of 3. So 2 square as a t square minus 1 whole square minus 3 whole square. Now this is a square minus b square. We can apply this. T square minus 1 plus 3, t square minus 1 minus 3. So a plus b, a minus b. So we have here t square plus 2 and t square minus 4. It's not done yet. This is okay, we cannot do anything more to it. But t square minus 4, again this is a square minus b square. So what are we going to do? T square plus 2 into, because why we are doing, the questions are usually factorize is completely. If we leave it up to this stage, it's not factorized completely. It can be further be factorized. So we have to do that. So t square minus 2 square. So now what are we going to have? Into t plus 2 into t minus 2. So this is factorized completely now. Okay. Now let's take one more example to evaluate some value, right? (41 square plus 738 plus 81). Okay, we have to evaluate it using identities. And if we see all the terms, all the numbers are positive, so it is this we have to apply. So a square, we already have 41 square, it is okay, plus 81, it is square of 9, so 9 square. Now what we need is 2 into 41 into 9. And if we multiply this, it is equivalent to 738. 41 into 18 is 738. Okay, so what are we going to do? We have this 41 plus 9 whole square. And 41 plus 9 is 50 whole square. And it is pretty easy to square 50, which is 25 double 0. So we have evaluated this by using identity. Okay, so this was all about factorization using identities. And with this, I think we have done enough for the chapter number 4. We'll conclude the chapter number 4 here. And do give me feedback regarding the factorization and expansion. Hope everything is clear now. And in the next section, we'll start chapter number 5. Thank you very much.